So the first question I was given was to ask if f of x and g of x were inverse equations. So one way to do this is to switch the values of x and y. So in f of x, if you switch the value of x for y and solve for y, you should in theory get g of x. If you don't, the equations are not inverse of each other. So what we did was x equals negative 3/4 times 2 times y minus 1, not x minus 1, to the power of 3 plus 6. So after solving all that, or solving all for y, by cube rooting to get rid of the power of 3, multiplying by negative 1/2 to get rid of the 2, we find out that f of x does in fact equal g of x, because these two are the same equations. Another way to do this is function composition, my personal favorite, where you take f of x and g of x and you make f of g of x, which in the end should equal x. So what we do is we take the original f of x equation, negative 3/4 times 2 times, now we replace x with g of x, getting this, negative 1/2 times the cube root of 4/3 times x minus 6 plus 1 minus 1 to the power of 3 plus 6. So after distributing the 2 and canceling out the 1 and negative 1, we can go down here and cancel out the cube root and the power of 3. Distributing the 3/4, we get positive 1x and negative 6. Negative 6 and positive 6 cancel out, x equals 6. Or x equals x, I'm sorry. So that's another way to solve, or to see if these two equations are inverse by using function composition. The next way to do it, a slightly longer way to do it, is to use coordinates. So using the original equation, f of x, we can plug our x values into the equation and find our y's. So I chose the x values negative 1, 0, 1, 2, and 3. Then I plugged my x values into the equation, as you can see here. All of these are my x values. And then we found that negative 1 is the y value 54, 0 is 12, 1 is 6, 2 is 0, and 3 is negative 42. Now, if they are inverses, we can plug in f of x y values, so the ones we just found, into g of x and receive the x values of f of x. So here you can see we took g of x and we placed 54, one of the original y values, into the x position of g of x. After we subtracted 6 from 54, we got 48. 4/3 of 48 is 64. The cube root of 64 is 4. Multiply that by negative 1/2, you get negative 2. Negative 2 plus 1 is negative 1, which is the original x value. Now, to graph this, it's really easy. You simply just take the coordinates that you got, and then you plot them. So for the original one, where we had all the points, I took and just plotted them. And then for the inverse function, after we found out by not only function composition, but also by switching x and y, and then doing that one example at switching f of x and g of x for the y values, I was able to plot the inverse function, where 0, 12 became 12, 0, where 1, 6 became 6, 1, and where 2, 0 became 0, 2. So that's the first question down. Now we are going to move on to graphing transformations. So next question gave me the equation f of x equals 2 to the cube root minus x minus 5 minus 10. 2 is our a value. Negative x is our b value. Negative 5 is our c value, and negative 10 is our d value. So the transformations that happen is it's steeper because a is greater than 1. A reflection over the y because b is less than 0, so it's negative, as you can see here. C is moved left 5 units, and D is moved down 10 units. The domain and range of this equation are all real numbers. And to find the x and y intercept, it's quite easy. So for the x-intercept, you just set y to 0 and you solve for x. So what we did was just 0 equals 2 to the cube root of negative x minus 5 minus 10. We divided by 2 and got 5 equals the cube root of negative x minus 5. We just raised 5 to the power of 3 on both sides, or we raised both sides to the power of 3, getting 125 equals negative x minus 5. We added 5 to get 130 equals negative x. And then we just switched the signs because we can do that, and negative 130 equals x. So that's our x-intercept. Now the y-intercept was slightly harder, just because it came out to be a weird decimal. But y equals negative 13.4-ish. It kept on going. So 2 to the cube root of 0 minus 5 minus 10 is negative 13.4. So this is what the graph looks like. So we had the y-intercept, then we had the x-intercept all the way at 130. Then we knew that it moved left 5 units and down 10 units from the origin, and that was another point we could plot. So that is what roughly the graph looks like. So the next question was asking about exponent properties, and it gave me the equation x to the power of negative 1/2 times y squared to the all to the power of negative 5 over 4 over x squared times y to the power of 1/2. So what we did was we distributed negative 5/4 and got x to the power of 5/8 times y to the negative 10/4. And since this is a negative exponent, we can move it to the bottom and making it 10/4. Y to the power of 10/4. So we moved it to the bottom. We simplified the fraction of 5 over 2. And because of the product of powers exponent rule, y to the power of 1 over 2 plus 5 over 2 gets you 6 over 2, which is y cubed. So because of quotient of powers, we can subtract 5/8 minus 16/8 and get negative 11/8. You simply move that down. You get x to the 11/8 times y to the third, which is over, or 1 is over x to the 11/8 times y to the third. Now that's in rational form. To make it into a radical form, it's quite simple. You can't make y to the third into a radical, but you can make x to the 11/8 a radical by simply taking the denominator and then rooting it to the power of 11. So it's the 8th root of x to the power of 11. That is the radical form. The next question was radical and rational equations. So what we did was we simply solved for x by subtracting 1 from both sides, then dividing by 5, by raising everything to the power of 2 to get rid of the square root. We took the root third of everything to get rid of the power of 3. We then subtracted 17 and divided by 4, x equals 16. So what we do is we bring that all the way up and plug it into the original equation to find out if it's an extraneous solution. So 1 plus 5 times the square root of 4 times 16 plus 17, all raised to the third power, equals 364. 1 plus 5 times the square root of 64 plus 17 to the power of 3. And then we move that down. 61 plus 17 is 81 to the power of 3. We can see over on this side is 531,441. Then we simply square that, and we get 729. By seeing this, we're basically working backwards. And then we do 1 plus 5 times 729, getting 3,645, plus 1 is 364. That means there are no extraneous solutions. So the next thing we did was we just simply isolated the radical. It's quite simple, really. All you do is you subtract 1, because that's all by itself. So you don't divide. So 3,645 minus 1 is 3,644. Oh, that's supposed to be 3,646. That's why, yeah. So it's actually 3,646 minus 1 equals 3,645. So now you simply divide it by 5 to get the rational by itself, and 3,645 divided by 5 is 729. That is all 4 questions. Thank you so much for watching this. Yeah.